man-made fibers. They are produced by polymerizing low molecular weight chemical substances, usually at high pressure and temperatures in the presence of catalysts. Melt spinning is possible with those polymers which give a stable melt like nylon 6,6, nylon 6, polyester, polypropylene, etc. Polymers which do not melt like cellulose, or those which do not give a stable melt like polyacrylonitrile, are converted into fibers by solution spinning. Polymer chips are fed into the chip hopper and melted in the extruder. The melt passes through the pre-filter and then through another filter fitted in the spinning head before entering the spinneret. As they come out of the narrow holes of the spinneret, they are solidified by cooling in a quench chamber. After applying a spin finish lubricant, they are wound on winders. Solution spinning may be classified as wet spinning and dry spinning. Wet spinning, the polymer is dissolved in the solvent and filtered. Then a metered quantity of the solution is fed to a spinneret dipped in the coagulation bath. As the fluid filaments are squirted out under pressure, precipitation occurs. The solid filaments are then washed, drawn in 2 stages, dried and wound. It may be noted that this is an integrated process in which drawing is integrated with spinning. Viscose rayon and polyacrylonitrile fibers are produced by wet spinning. Dry spinning. The filtered polymer solution is fed at the top of the setup, and a metered quantity of the solution after passing through a candle filter enters the spinneret. The filament bundle falls into a drying chamber where the solvent is made to evaporate and the solidified filaments are then wound. The drawing is done separately. Polyacrylonitrile, spandex and viscose rayon fibers can be produced both by dry spinning and wet spinning. Natural fibers versus man-made fibers. The long molecules are oriented in both cases and show the presence of both order and disorder in the way molecules are organized. The ordered molecules contribute to durability, strength, stability, and recovery, while the disordered region make a contribution to elongation, dye, and moisture absorption and toughness. The natural fibers show much greater non-uniformity than man-made fibers. Another important difference is the complex morphology of natural fibers as opposed to the rather simpler morphology of man-made fibers. A third important difference is that natural fibers absorb a greater amount of moisture because they contain more water absorbing groups than the synthetic fibers. Viscose rayon, a man-made fiber, absorbs a significant amount of moisture because of its cellulosic structure. This makes natural fibers and viscose rayon more comfortable in the form of apparel wear, particularly in tropical and hot climates.